All right, let's do it. Today we're going to look at deriving an instance of eq, or my eq, as I've called it. Yeah, let's get into it. I've got a pretty basic setup here where we've got a product type and a sum type and just some examples and printing stuff out. And so let's get down to it. Just like last time, what we need to do is extend this K0 derivable, and then that's going to give us all of our things we need to implement here. And just like before, we get to copy this. I'm going to say that in every video because it annoys me greatly, and I hope somebody can do something about it, because I imagine that has to be possible to have a way to figure that out, that this actually isn't implemented until an object. Anyway, so let's get down to it. All right. That's not going to work. So what we need to do is we'll start with this not supported. Oops. Not supported. Keyboard's fighting me today. Okay. Now it should say not supported. Perfect. Okay. So now we can actually implement it. So we're going to implement this in the same, using the same helper as before, where we're going to have our instances cached outside of our type class here. And then driver, my boom. And now we should be compiling. Almost compiling. We can do that for now. Okay. And let's get rolling with this guy here again. Then meta a0 invitation for variation for my eq. Okay. You can see here that our instance is just triple question marks because we haven't done anything yet. Okay. So now if we do new my eq, do that. Now we've at least got an instance here, and our function is just not implemented. So let's implement that. So these are taking expressions, and this is our little helper. We're going to convert these actual values into expressions, and then convert the expression back. Okay, so what do we got so far? We'll throw this on that, and we can have these again. Awesome. Okay, so we still just have our triple question mark because that's all our helper does. It's basically the same thing as before, is just give us an expression of not implemented. So what do we want to do here? We have a product type, right? So like our person. And so what does it mean for two person classes to be equal is all of their fields should be equal, right? So what we can do to do that here is we're going to use our trusty generic, and we're going to map. I'm going to create a little helper here. Val, say booleans. Say it's a list of an expression of boolean. Okay, and we're going to map children, and then we'll say map expert of boolean, and then we get to have our fun polymorphic function, which just takes a little bit of getting used to, right? I already typed to my sleep at this point. There we go. Okay, and so now what do we want to do? we want this to be, we need to get our Typeclass instance. So if you followed along in the last episode, the way we do that is we do field.getExpression or getExpr, and then this is now a expr of my eq of b. So on the outside of here, we have, it's not labeling that correctly, but technically this is, we've interpolated our expr, so now we just have a my eq. So with a my eq, we use this is eq, and now we can interpolate the actual a and b. And so here are our values a and b, but these are exprs of a. We need to convert these into an expr of b, since this type class instance, right, it's not an x or my eq of a, it's an x, it's the my eq for the field. So the way we go from an expr of a to an expr of b, if you followed along in the last episode, we use this from parent. And then we do from parent a, from parent b, and then we need to convert this into a list. Okay, well, that's because we got triple question marks. Okay, so now we have this list of expression booleans, okay? And so if, let's match on these booleans. Right, if there's no field, then we can just go ahead and say they're equal, because that's like a case object or an empty case class. There's nothing to compare. As long as it's the right type, then they're just equal. If not, we can do this tail fold left, and we'll do head, and then we have an ac bool. These are both expressions of booleans, and the way we combine these, we need to interpolate it. Ac and bool. Amazing, and we're done. So let's look at what this is actually giving us here. So here it's doing is eq for the first, like person.first, is eq for person.last, and is eq for age. Awesome. So let's move this back over, and we should be able to run our example here. This ever decides to run. No. Oh. No warning. Cool. So we were able to run this. So is person 1 equal to person 1? True. Is person 1 equal to person 2? No, they have different stuff. And is person 1 equal to person 1 different age? No. Okay, so now if you followed along in the last episode, you saw that we can use annotations in order to control how our type classes are derived. So let's say for whatever reason, we don't care if this age field is equal, just an arbitrary thing that we can do to our type class derivation here. So what we can do is we can have a final class called ignore. Extends annotation. Scala annotation. Okay? And now let's, like we said, let's arbitrarily add my ignore. Right? And you can see that our age is still showing up here in our comparison. Because because we haven't actually done anything with it yet. But it's going to be pretty easy here. So all we have to do is option.when field annotations optional of ignore dot isn't. So we want to have the expression when we don't have the annotation here. So now this is an option of expert boolean. Flatten it. Flatten it. And now we can see, as if by magic, the comparison of age has completely disappeared from our instance or our derived type class. And now if we run this, we should see true, false, true. Ta-da! Amazing. Okay, let's keep moving. Let's do sum types now. So what exactly does it mean to have sum types that are equal? Well, first of all, if it's a cat, if one is a cat and one is a dog, they're not equal. Or if one's a cat and one's a squirrel, it's not equal. And then, but if they are both the same, if they're both cats, both dogs, both squirrels, then we test whether the subtype is equal. And that is going to be super easy. So let's go do it. Here we want with instances of my eq a do, and then we're going to need a new derivable some deriver my eq a. Okay. Same thing as here. And this, just copy it over. Okay. All right, now we're rolling. Okay, so what we're going to do here, there's a helper to do this, but we will make it a little more complicated on ourselves just so we can kind of see what's happening under the hood. Okay, so we want a match builder. Match builder is, we need to import that. It's in this oxygen meta. We have a match builder, and we want a match builder of A to Boolean. Okay? And then here we can do match builder 1 dot match on. Actually, we don't want an A. That's my bad, sorry. We want a tuple of A's. So we're going to match on A, B. Okay? So we don't have anything really working yet here, so let's actually do our match builder. Okay, so we are going to do generic matcher make. Okay? Private type I have two. Just for fun. I have two is going to be A2, A2. So it's just a tuple of both of them. We're doing that there because this requires a it requires us to have a little type here, and so that's how we're going to do it, just to make our lives a little easier to have an alias. Or we could not have an alias. Why not? We can do it. We can do it the fun way. That we have two of them, and then the output of this is going to be a Boolean. I believe that is what that means. Yes, out type in. Okay. Awesome. Cool. So now we get to make our theme. Make our theme. so descriptive. What we're going to make is the match builder, which is it's essentially going to build a match statement for us, and it provides us some nice helpers to be able to do so. Generic.case B. Awesome. Okay. So now what we want to do here is our case here has this nice helper specifically for building these match builders. And what it lets us do is it's making the unapply or the bind or the check. So we'll see that in a second. We need to give this a name because we're going to have two of them. Normally you can get away without the version that has a name. B. And then with right hand side. So here we're going to have our A and B. And what do we want to do? So this is essentially, it's not going to give us the type, unfortunately, because the macro is getting confused. But this is an expert of B, and this is an expert of B, and that is this B in our polymorphic function. And so if we have one of these children, whether it's a case or a field, how can we get our type class instance for that child? Is we do case get expression instances, and so now this is the expert my_eq of B, similar as we had before. And we do this. We kind of go back and forth between expression land and not expression land, and then we do is speak A and B. And did that work? Awesome. So now what happens if we try and do this? Ooh, non-exhaustive pattern match. We don't like that. What can we do about this? Okay, so is it showing us what it derived? Yes, it is. Okay, so we can see here that this is no bueno, right? We're matching on two instances of animal, and we get our nice pattern matches here, but we have this case at the end, which what happens if they're not both squirrels or both animals or both cats or both dogs? They're always animals. But what do we do then? What we do is we need to add a wildcard case. So with wildcard, very easy here. It's just false. Awesome. Now we have our else case essentially, which is just false. And we should be able to comment this out. Amazing. Okay, so now what do we have? We have cat1 equals cat1, true. Cat1 equals cat2, false. False as expected. Dog1, true. Awesome. Here, awesome. And you see, you can guess what we're about to do. All of these annotations behave exactly the same here. We can add our my_eq ignore. Add that in. Run it again. And this should switch to true. With all of this staying the same. Amazing. And you can see if we go up to actually look at dog, the instance of dog, here we're only comparing the names. And if we get rid of this, now for our dog, we're comparing name and breed. Cool. So that is our instance of eq. Next, we'll be doing monoid. So hang in for the next one.